So who can give me the explanation of LAN?
So local area network.
Local area network, right? So like Wi-Fi, what it will be?
Wi-Fi will be LAN.
Wi-Fi will be LAN. So if you have a network that connects some computers in a local area, that will be called LAN. So you might have seen Ethernet cable, right? Like your router in your home, that creates the hub of the LAN in your house. So within a house, there is it creates a local area network, either through a wire or wireless. So Wi-Fi is an example of a LAN. And what is a WAN? Wide area network, right? So internet is a WAN. There can be a private WAN also. Like you have an office that has 50 branches, and you create some kind of network that connects all those branches, and they are spread out, then that will be a WAN. What is internet? Internet is an example of a WAN where a lot of nodes connect to a lot of servers, and you have redundant communication and everything. Of course, there's a lot of things, but I just wanted to throw out some of those things so that we know some of those terms. And data center, when we talk about internet, then there are some centers where you can store a lot, where you have a lot of servers, you can store a lot of data and software. That's called data center. And cloud is some representation of data center. But anyways, this is not our main topic anyways.
Okay.
Go ahead.
No, with the previous one, I think an easy example would help. So anything that, suppose a picture that we upload or a video that we send on WhatsApp to one another, the exchange that you will have on the WhatsApp group, that actually goes to the data center. So that's how it's in the data center. And then what a lot of companies are doing is they are, rather than having your own data center, you need so many computers and racks and this and that.
Stores.
Yeah, stores. So they say they don't want to store it themselves, or so they give it to someone. And when you give it, if I give my data all on the computer to Bari, I would say this is cloud now, because it's up to him, he can take it in the cloud. So it's just too easy to understand.
Right.
So all those,
Yeah, very good example.
the WhatsApp videos, the pictures, everything is actually going to data center, and then eventually some other company like Amazon, Azure,
Right.
that's cloud.
Right, that's a very good example.
So
Facebook.
Cloud, you will say that cloud is what?
So cloud. So just a cloud, of course, is cloud, right?
Yes.
But
They call
when
it
we say
cloud.
cloud computing, usually, so cloud has two different things. Like one is cloud computing and one is cloud storage. So if multiple folks use some common data center to store things, that becomes where you don't have to know where exactly this thing is. So if, just like he gave a good example, if I upload a picture on Facebook, right? We don't know where it went. It might have been saved into a data center in Raleigh or in Virginia or maybe somewhere else. I don't care, but I have an access to it. That is a cloud storage. The cloud computing is that I want to do a lot of computing, but I give it to some server out there in a server place, and it computes for me. That's a cloud computing.
I just want a quick one, because this is a fresher class, so most people are very new and fresh. I think the best would be if you Google data center and show them a picture, and then you Google cloud and show them a picture. So, because when I was learning this, and the teacher was saying, I was like, what is he talking? What's data center? What is this? So if you just put a few photos in, so visualize, and then at home you can check a video or something, because computing is all interactive, so you have to actually absorb as to what's going on. Otherwise, it's very simple, but when you look at it, it becomes very difficult.
Where is
So
it?
just-
I don't have
Wi-Fi
Wi-Fi yet.
or extension, yep,
Yes.
capital R. And one example is these days, Facebook. A lot of people are saying that our pictures are being compromised. You know, there was a data breach. So data breaches, you give Facebook all your pictures, and then they sell it to someone else. So that's why so they say be careful at what you upload, because your data they can sell to other people.
Okay, so data
So that's
center
it. Yeah, that is it.
image, right?
So this
So-
is a data center.
Say for example, this is a data center, right?
And let's put this.
Now, usually this actually is a data center, right? What it shows is a lot of racks, and then each rack has a lot of servers. Each server is a very big, powerful computer, and they are connected through other computing sources, right? So that's usually what data center is. What else? Like
Cloud.
cloud image.
Yeah, cloud. Let's see what it says. It might bring a cloud in. So
Yeah.
cloud,
Cloud storage.
cloud storage or something. Cloud storage.
Storage.
Image on the top. Images.
Yeah.
It's actually bringing a cloud in. Sorry.
So cloud storage, for example, top 6 free cloud storage. But anyways, so this means, and some of those, it is there because you guys can kind of look into it and
They also
research about it.
Yeah. Just to make it a bit spicy, cloud storage they say is the storage of Dajjal. So, and basically, you're storing every single thing that whatever you do, your apps, your iWatch, the where you go, where you come, credit card you use, every data actually goes into the cloud, and then they can actually work on it, and so it's good to know these terms and understand it, because
Right.
when you-
One is virtual, and the other one is physical, right? So data center is physical, you can actually see the elements, you can see the servers and everything. Cloud is virtual, you can't see it. Someone actually has
But it's
something
in
out there.
You cannot see it, but it's in
Yeah,
there.
it's there, right? You're putting it there, somebody's actually managing it, they might have a physical, but to you it's virtual.
Right.
Like, how you have the software and the hardware, the
Right.
computer
Right.
explanation, that's an extension of it, right?
This is
Yeah, something I just.
yeah, similar thing, right? So we'll just go quickly to a simplified computer architecture and just like the same things that I was talking about. A computer has a CPU, which is the central processing unit. So it's a processor. It has some memory, and then it has a disk controller, some video stuff, sound, network adapter, how it connects to the network, and Wi-Fi, the I/O ports that connects the keyboard, mouse, printer, and modems. So a computer, while it's one single thing, it has a lot of other parts that make up the whole computer, that makes it more interesting for us. Why some of those things that I'm putting in here? Because once we start programming, we will know that we will start using, say, keyboard, or we will want to put something onto the screen, or if we could go there, we can do some network programming, like send something, or even HTTP, which means a web kind of request or something, or database or something. So we'll go through some of those concepts which kind of build upon all of this. So it'll be good to understand this. Of course, we cannot explain a whole lot about it because it takes a lot of time, and this is not the main idea of this course. But this is something that you guys should know once you go through these PowerPoint after I send it to you, then maybe you can Google it, look at it, understand it a little bit more. If that interests you a little bit. If that does not interest you, that's fine too, because as long as you know a little bit, then it's fine. All right, so programming languages. So let's start with programming. What programming language, can you give me some other programming language name other than Java? Okay, no problem. Yes. C.
plus.
Okay. Ruby.
C++.
C++. For the moment.
Is Perl a programming language?
Perl is like
Or
a
is it
programming
scripting?
language.
Yeah, Perl.
Scripting,
And
yeah.
Python similar to that.
Python is similar to that, sister. You don't know any other programming language name? That's fine. You are just looking at. That's fine.
I used to know Logo.
Logo, okay. And what about you, sister? Any other program? So, of course, so that, but at least from these answers, you know that there are so many different programming languages. Now, one of the things is that why there are so many programming languages if there is one type of computer, or there is a computer, there is a processor. Why there are so many different languages and how they are different? So one of the things, that is the very basic things, is that a computer CPU does not know about programming languages. It runs its own programming language, which is like this, which is binary, which is 0, 1, a bunch of 0, 1 that eventually can be translated into hexadecimal or something, but a processor just only know a binary language. Now, to understand binary language, they create a language which is very close to that binary language, and they call it assembly language. So theoretically, a processor only knows about its own language. It's kind of difficult to understand, right? But processor is a chip that works only on binary, 0, 1. You might have seen sometimes, right? So, which means that people, after creating the processor, they created some higher level languages that we can easily understand. And then behind the scene, they translate that high level language into that binary language so that the processor can run. So this is a kind of like a simple and important thing, because we will go through some of those issues when we'll start working on it. Not an issue, but we'll go through some of those steps. So again, let me try to rephrase it because it's an important kind of point, is that each processor has its own language, which is very low level, which we cannot read or understand, that it actually runs. To make it understandable for us, they have created some higher level languages, so that, but processor does not know that higher level language. So they use the same processor to take that R program and then convert it to the low level machine language processor executable program. Make sense or does not make sense yet? Make sense?
Makes sense.
Correct. So it's kind of like conversion, right? So if machine understands something, we understand something, right? So there is a step in between. We convert. So because sometimes you write something, right? Machine does not understand it at all. You have to go through a conversion process, make it a machine understand. Translate, right? Now, there are so many different types of processors. Like my Mac has different processor. That is a different Mac, and it has a similar processor, not exactly the same. They might understand each other's program, maybe or maybe not. If my Mac is too old, then a new Mac might not understand the same program. This happens less in the Mac, but more in Windows. An old Windows program, 32-bit machines, remember? Now 64-bit machines and stuff. So there are so many different processors. To make it a little bit easier, they created a software. So initially they created a software which is called C language, which was very understandable but very close to the machine, ran very fast. Then they say, it works fine, but we need something a little bit different. So they created, say, Java, for example, I'm just saying it. And then somebody else needed something different, something to be done differently for some different application. So they created another language. But each language, whatever you have, eventually is translated into the machine language. While each machine can be different. So I write a software in Java, right? Or C, let's say, for example. I translate it for my Mac. Now I take it and I go to Islam's computer and I run it and it does not run. Why? Because it's a different machine. So it's it needs a different machine language, which means that the same program will have to be translated for his machine and things like that. So there are a lot of permutations of it that makes it very challenging and very interesting also. And that's why I brought up this programming language concept to explain a little bit about machine language, then a little bit about assembler language. Initially, long time ago, when there was no higher level language, or even when there were some higher level languages, they had some human readable languages which were called assembly language.
Basic.
Not basic. It's assembly language. It's only called assembly language. But it's a different assembly language for each processor. And then you still have to translate it, but at least it was very, very close to the machine language. So it was same machine language, instead of in bits and bytes, it was in some kind of command and data. Then there are high level languages. C is an example, C++ is an example. And then there are so many. Brother Muhammad did you say Perl, right?
Mm-hmm.
Perl is so in a higher level languages, there are two types of languages. One is called compiled language. One is called interpreted language. Compiled language is the language where you compile it first and then run it. Interpreted language is where there is an interpreter which takes in the program and then runs at the same time. So Perl is an interpreted language. C is a compiled language. We'll maybe go through this. I know it's getting boring, but we'll go through it sometime. What about Java? What kind of language is it? Is it machine language? Is it assembly?
Assembly, yes.
Compiler, no?
It's compiled.
It's compiled.
So it's not machine language. It's not assembly. Number one, it's a higher level language. A higher level language is that where you can write things that you can understand a little bit easier. It has its syntax and stuff which is easier to understand. Then you can do a lot more in a higher level language. Of course, you have not gone. So Java is a higher level language, but it is compiled to some extent, and it is interpreted to some extent. Interestingly, and we'll go through it once we have time and once we go through some of the initial steps, because I don't want to make it a very boring discussion. It is very interesting for me But for new people, it could be a little bit boring because we're talking about.
Don't look at our eyes and think it's boring. Some of us were getting up for work, we've been up all night. In fact, I'm gonna stand up so I don't fall asleep.
I know, yeah.
No, it's not boring. Huh? No, I'm tired.
Sure.
Keep going.
Or we'll take 5 minutes break so that people can walk a little bit and then check on their kids and stuff.
Has Islam already started programming?
Yeah, looks like it.
Or he's not focusing on the lecture?
Oh man. Oh man. You downloaded it, huh?
I downloaded it, but it's like not working on my.
Is that a 64-bit or
I did
32-bit machine?
download the Eclipse.
46.
Looks like
Is
it's
it 64-bit?
working, but now it's asking me to install a JD.
Right. DK.
DK. Yeah.
Right. Because you should have installed JDK first. But it's not a big deal if you go through the steps, because the instructions that I sent, it has separate one, like a link to install JDK.
I think it's only 2 links, the one that you sent.
The one that I sent
But I think
And,
that doesn't need to be. There are 2 different kinds.
If I try to open it,
This
it'll.
is-
Computer by
If I try to open it, it'll.
No.
download.com.
JDoodle, just go to any a browser and just write jdoodle.com.
Did you download
And
it?
I'm gonna have this one.
Yeah.
And then you don't need an Eclipse.
Not the Eclipse, there's 2.
What time is this class going to
What time the class
Yes.
ends?
Yeah,
In 1 hour.
So you have to.
Okay, I gotta go. I have exams tomorrow. I can't stay for an hour.
You have
Oh, you have an exam tomorrow.
Yeah, I gotta go.
So you have to watch the whole video then.
JD.
Okay,
1
yeah.
hour.
You have the link in the WhatsApp group, right?
I will, no, it will be uploaded into, yeah. There's a link and it will be uploaded to the channel.
The history.
What's the channel?
Find the link.
I will let you know, don't worry.
Okay.
When I'll upload, I'll give the channel and everything.
You going?
So if you
I
go
have
to
exams tomorrow. I can't stay for an
jdoodle.com,
hour.
so, right, so you have to install JDK, right?
Assalamualaikum.
And then we'll talk about that process in a second. But in the meantime, you can go to JDoodle and then you can click on Java. And you can see that, we will go through it a little bit, but JDoodle is a very easy and convenient way that if you don't want to go through Eclipse and JDK and everything, then you can just use JDoodle. For most of our course, JDoodle is good enough. But Eclipse is even better because you can do a whole lot more with Eclipse, right? So you can try JDoodle.
Yeah, I'm trying it. It's like loading.
It's slow.
Yeah.
All right, and then.
So since I already have those Eclipse,
Hmm.
so do I still have to go to JDoodle?
No. You just need to install the JDK, right?
JDK, right.
So if we go here, let's see. And if you guys are like too bored to death or something, then we can, this is this orientation class, we can give you 15-20 minutes. We can leave a little bit earlier. But, so, sister, you can see 1.2, how to install Eclipse on Mac OS. So first you have to install the JDK
Okay.
for Mac. So you have to go through that. If you're having any problem, send it to the group, and then anybody can kind of jump in and try to solve the problem or help out. So, okay, we will start in a couple more minutes.
Probably next week could be my last week. So I think I'm on a new project. So
Uh-oh. In New York?
they've given a few locations, so I have to choose. I might be going to Virginia first, Northern Virginia, DC. Yeah, I see.
Son is there.
Oh, your son is there?
Yeah.
I can connect with him because,
Yeah.
yeah, I might need to connect with him.
Not in DC, but like 30 miles.
Towards Virginia?
Yeah, in Virginia.
I'm going to Virginia. My head office is in Tyson's Corner, Virginia.
So yeah, he'll be like 20 miles from Tyson Corner.
Okay, so I might connect with him. Yeah, that's good.
All right, we'll start. So next week you will give a small lecture.
Yeah, absolutely.
Next week you are here, right? All right, we'll start with a small lecture from Brother Majid Khan on some of the uses of Java and where Java can take us to and things like that. So let's go back. What is a program? When you say programming, so what is a program? A program is basically two things. What is shown here? Objects or data. Why I said objects or data? Because when we're talking about Java, Java is called object-oriented language. What does it mean? We'll talk about it maybe. But instead of saying data, it calls data objects. Because data is not, like pure data is not object. But it calls data somehow as an object. So, for our main understanding, what is a program? Program has some data and program has some operations. And this we will start going through very quickly. What does it mean? Whole big program has some data and some operations, almost like that. So usually any program, what we talk about, an app or a computer program, or what is running maybe in this system, there is some data. And then there are some other things that operate either on that data or on memory or on I/O or something. So when we are talking about writing a program, we have to know both of those things. What will be our data and what will be our operations. So, for example, if we say, okay, we want to write a program. Now, this again is a little bit of boring, little bit of introduction. We're not diving right away into programming, but this will help you a little bit in understanding how we write a program and what is the better way of writing program. So, what we are saying here is, say if we want to write an application. Application means a program, right? So, what we want to write is to be able to find name by addresses or addresses by name. So we have a program that does a search. I give it a name, it finds me an address that corresponds to that name. Or if I give it an address, it searches and it finds me the name that corresponds to the address, right? But what are the objects for it? First of all, I need to know what I'm searching for, like the person. So, the main thing is I need to have a data, name and address registry, right? If I don't have that data, I cannot search anything, right? It's not like wild search in the suburbs or something. It is like you have to have that data, right? So you have to have a name and address registry or a list or some kind of data that you would search into. And then there will be, the first thing is there is somebody who has to give something, right? So there will be a user of it, right? So why I put user also in it? Because you have to understand who will be doing the searching. If the search is, say, by a computer, because a lot of time a computer is searching another computer, or a search comes, where the search is coming from. Somebody is going on the computer and giving on the keyboard, then your program should have a way to take the input from that person. You understand what I'm saying? So if I write a program, but I do not give you a way that you can search on it, and although it has all the operations, it cannot take the input. So you have to take the input and you have to have the data. Now, what is the operation? The operation is request name by providing address, or request address by providing name. So, why it does not fit?
Yeah, I think you have to adjust the lens on the projector.
No, it is not even show in my. What would you add in object and operations to provide the ability to add to registry? Now, I have this, say for example, you have this application, right? Now, but people in the registry, people come and go. But so at least for me to be able to add something to this registry, what do I need here and here, right? So you understand what I'm saying? You understand what is the ask here? So I have an application, right? That has these two things in the object. One is that somebody can input a name or address. The other thing is it has a full list of addresses and name. Then it has two operations. You give it a name, it will go to the list and give you the address. You give it an address, it will go to the list and give you the name. But now I want somebody came into our subdivision. I want that person's name to be added to the list. Very simple thing. We're not going into any detailed stuff. We're not going into any complicated stuff. Just I want to know what we need to add to the object and to the operation so that we can add one entry into the registry. Very simple thing, but it's a homework. You just think about it and then maybe just write your answer into the discussion board, right? But it's very simple. And I'll send you this presentation also. So, but all I'm saying is we'll add something to this so that now this application is not just a search application, but it also can add a name to the registry also. Right? Kind of simple, but maybe it is not making,